Hi everyone. Today we're going to be factoring a quadratic expression. Before we start doing it, let me explain what those two words mean, factor and quadratic. Well, start with quadratic expression. Uh, Here's one I've already got it written down. I'll write it out again. A quadratic expression is any um, expression where the highest degree on any of the terms is 2. And as you can see, there's the 2. The word quadratic actually comes from the Latin word quadratus, which means square. So, and if you were ever wondering, because a lot of students I've found don't even know what the word quadratic means. It just means square. It's the Latin word for square. And as you can see, the x has been squared. And that's why there's an exponent 2 right here. So anytime the highest degree in a term is, in an expression that you see is as a square or a 2, then that's called a quadratic expression. That takes care of the word quadratic. Uh, that word right there. So let's take a look at the word factor. Not everyone knows what that word means either. So let me just give a quick explanation. To factor something means to take something, usually something complicated, and to break it down into smaller chunks. So for example, if I had the number 30, that's sort of a big and complicated number. I can break that down into, for example, 30 divided by 5, and 5 times 6 gives you 30. What I've done there is I've factored 30. 30 is equal to 5 times 6. I took 30, which is like a big complicated number, and I broke it down into smaller chunks. 5 and 6 are much smaller numbers than 30, and when you multiply 5 and 6, you actually get 30. So I factored 30 into 5 and 6. But if you look a little closer, I haven't fully factored it. The number 5 is fully factored. It can't be broken down anymore because it's a prime number. But the number 6 can be. So the number 6 can be broken down further into a 2 and a 3 because 2 times 3 gives you 6. So if I were to break that down even further, well, the 5 stays. That doesn't get changed, but the 6 breaks down into 2 and 3. And look what I've done. I've taken this complicated number 30, which is a big number, kind of hard to work with, and I've broken it down into smaller, I guess you could say bite-sized chunks, if you want to think of it that way. If you have a piece of bread, a big piece of bread, you don't eat it all in one bite. You bite it, and you break it up into smaller bite-sized chunks, and you take bites of that bread. And because the smaller chunks are easier to handle, easier to work with. So 30 has been factored down into 5 times 2 and times 3. And all the factors of something, if you were to multiply them back out, you've got to get the original number as we do in this case. 5 times 2 is 10, 10 times 3 is 30, and that gives us back the original 30. And so that's the idea of factoring, taking something complicated and breaking it down into 2 or more smaller chunks. That when you multiply those chunks back out, you get the original number. And that's what we're going to try and do with this equation. I'll write it out again. It's 3x squared minus x minus 14. This equation's in standard form, and standard form always looks like this. It's something x squared plus something x plus a number. All you got to do first of all is look at your equation and identify what your a, b, and c numbers are. So let me do that right away. A is the number in front of the x squared. So in our example, that would be plus 3 or positive 3. B is the number in front of the x. And so in our example, you see a minus sign in front of the x, but remember there's an invisible 1 there as well. So the b number is minus 1. And the c number is the number all by itself without any x's onto it, attached to it. And so that's this number here. It's negative 14. So we've got our a, b, and c numbers. And here's what you have to do. You have to find two special magic numbers, two special numbers. And those two numbers have to multiply to give you what a times c is. And they have to add to give you the number b. So in this example, a times c, a is 3, positive 3, and c is negative 14. And positive 3 times negative 14 is negative 42. And the b number is negative 1. So we need to find two numbers that multiply to give you negative 42 and add up to give you negative 1. Let's try and find those numbers. We'll do that on the side over here. So our job is to find two numbers that multiply to give you negative 42 and add up to give you -1. First, let's write down all the pairs of numbers in the world that multiply to give you -42. Let's start with 1. Well, there's 1 and -42 itself. Then, of course, there's the opposite sign version. There's always the opposite sign version. Same numbers with the opposite signs, -1 and +42. After 1 comes 2, and 2 times -21 also multiplies to give you -42. And then there's the opposite sign version, -2 and +21. And then after that is 3 and -14, -3 and +14. 4 doesn't divide into 42, neither does 5. After that comes 6 and -7, and -6 and +7. After 6 comes 7, but we've already got 7 here, so that's it. Those are all the pairs of numbers. I guess you have to know your multiplication tables pretty well, or you can use a calculator, but you have to come up with all the pairs of numbers in the world that multiply to give you A times C, which in this case is -42. Now, one of these pairs of numbers will also add up to give you -1. So just go down the list and see which ones add up to give you -1. Or does +1 and -42 add up to give you -1? No, it's -41, so that can't be it. -1 plus 42 is 41, not -1. Uh, this didn't give you -1, it's -19. These two add up to give you +19. These two add up to give you -11. -3 plus 14 is +11. And then we get to this, +6 and -7. Well, if you add up +6 and -7, that's the answer. That does give you -1, so that's got to be it. And of course, -6 and +7, this can't be it because they add up to give you +1, and we're looking for -1. So we just found out our two special numbers. They're +6 and -7. +6 and -7. Now that we know our two special numbers, we're going to continue the question over here. Let me write the question out again. Y equals 3x squared minus x minus 14. We know that this middle number, the -1x, can be split up into +6 and -7. So that's what we're going to do. The first term stays the same. The last term stays the same. But this -1x, we're going to replace it with +6x minus 7x. So as you can see, before we had 1, 2, 3 terms. Now we've got 1, 2, 3, 4 terms. What we're going to do now is factor. There's no common factors, but what we're going to do is put your hand over the last two and factor only from the first two. This is called factoring in groups. So if you look only at the first two terms, we realize we can factor out a 3 and an x from there. And then what's left after we take 3x out of the first two terms? Well, there's x, because 3x times x gives you this 3x squared. And then 3x times this +2 gives you +6x. And that's the first factoring. And now we look at the last two terms, and we realize we got a -7x and a -14. And from those, we can take out a -7. What's left? Well, -7 times what gives us -7x? That would be x. -7 times x gives us -7x. And then -7 times +2 would give us -14. And there's our factoring by groups. If you take a look, before we had 1, 2, 3, 4 terms, right? 1, 2, 3, 4 terms. Now we've only got 1, 2 chunks. And if you look closely, those two chunks have something in common. They each have an x plus 2. So since the x plus 2 is present in both of those, we can factor out an x plus 2. Well, what's remaining? After we take the x plus 2 out of here, there's still the 3x remaining, so that goes in here. And after we take the x plus 2 out of the second part, there's this -7 remaining. And that's what goes in the second bracket. And as you can see, we have now taken this, we have now obtained this factored version of the original quadratic expression that we had that was originally in standard form. And we have done this, we have done factoring to get this into a factor form. So if you were to if you wanted to check to see if that this answer was correct, all you'd have to do is FOIL it. if you remember FOIL, we have a video on FOIL if you want to take a look at that. That's also on our channel. If you were to expand these, if you were to multiply everything in the first bracket by everything in the second bracket and add it all together, you'd see that this factored form version was exactly the same as the standard form version that we started out with. If you were to draw or graph this function and then graph this function as well, you would see that those two functions are identical because they would give you the same identical graph. And that's the end of the explanation on how to factor a quadratic expression. If you found the explanation in this video helpful, please click the like button and let us know in the comments. It would really help the channel and help us to continue to bring you more free videos. And also can click the subscribe button too, because subscribers get to send in their questions to us. And if it's not a question that we've already covered, we may create a video on our channel with the solution to your question or a very similar question if there's any copyright or liability issues. So please subscribe and send us your question to solve right now. Let your friends know if they're in math classes and they need help. We're trying to get every possible uh, question that you would ever see from grades 6 to 12. So that's middle school and high school on our channels. And the videos are free, and they'll teach you how to do every single type of question you'll ever see in math class. And it's like having your own personal math tutor for free. You can send your questions in the comments below or through our website. We've included a link in the description below where you can send us your question. Thanks for watching, everyone. Bye.